In this lesson, I will demonstrate how to sketch the graph of a logarithmic function. In this diagram, you see the graph of an exponential function and a logarithmic function. These two functions are actually reverse functions. They're opposites of each other, and they are a reflection across the line y equals x. Let's discuss some of the properties of graphs of logarithmic functions. So they all have the general properties of a domain being from 0 to positive infinity, which is sort of opposite of an exponential function. Recall, exponential function had an asymptote at y equals 0. It had a horizontal asymptote, and it sort of kind of sat on the x-axis, but not touching it. And the logarithmic function is just the opposite. It kind of sits on the y-axis, but it doesn't touch it. But it has an asymptote as well, but it has a vertical asymptote at x equals 0. So again, a log function and an exponential function are complete opposites of each other. So again, number one of the properties of a log function is that the domain is from 0 all the way to positive infinity. And the range extending up and down would be from negative infinity to positive infinity. Notice it has arrows on both ends, so it's going to go forever in those directions. And as I said before, this one has a vertical asymptote, and that vertical asymptote cuts through the x-axis at 0. So the vertical asymptote is x equals 0. The other thing is 3 points that you can always find on the graph of a log function. You will find 1 over b, b being the base. So 1 over b comma negative 1. There's also an x-intercept at 1, 0. And then there's a point b, 1. In terms of whether it is a growth or a decrease, if b is greater than 1, then the function would be increasing. So in the first example here, it is where b is greater than 1, and notice from left to right it will be increasing, moving in an upward motion exponentially. And if b is a fraction, such as in the example of the second case, then it would be a decreasing function from left to right, moving in a downward motion. And there you have it, the properties of logarithmic functions. So just a recap of these two inverse functions. You have the exponential and logarithmic functions. Their properties are similar but not the same. So with the exponential function, you have a horizontal asymptote, and the domain is from negative infinity to positive infinity. Range is from 0 to positive infinity. And you have certain points that are on the graph where it touches the y-intercept and 2 other points. The logarithmic function, the domain would be from 0 all the way to positive infinity, and the range is from negative infinity to positive infinity. It has a vertical asymptote which passes through the x-axis at 0, so x equals 0, and it has an x-intercept of 1, 0, and 2 other points there. So again, these functions, although they may look very similar, they're sort of opposite in nature. They're inverses of each other. In this example, we will sketch the graph of f of x equals log base 3 of x, and then give the domain and range. Well, the first thing to note about a logarithmic function is one of its properties is if the base is greater than 1, as in this case, we can see our base, log base 3, our base is 3. So if our base is greater than 1, then the function would be that of an increasing function, which means from left to right, it would be moving in an upward motion. Also, other characteristics of a log function is that it will kind of sit on the y-axis, and the domain would be from 0 to positive infinity. So you would see your line moving in an upward motion, getting greater as it leaves 0. So as it approaches positive infinity, it will increase. Other characteristics, there are 3 specific points that are on the graph of a log function. And recall that is 1 over b, comma, -1. You also have a point on the an x-intercept at 1, 0, and you have a point b1. So if b is 3, then we would have a point at 1/3, -1, 1, 0, and 3, 1. Let's go ahead and sketch those points. Also, don't forget we need to sketch our asymptote. That will kind of help guide your sketching of your line. And it's going to cross the x-axis at 0. So it's going to be at x equals 0 line. So once we do that, we can go ahead and sketch our points, and our graph is going to look like so. Notice we have our points over 1/3, down -1, over 1, stay at 0, over 3, and up 1. So yes, our graph, even though it looks like it is touching 0, it is close, but it's not quite on there. But this line will continue on to positive infinity as it increases. It is a function that is increasing on its interval. And there you have it. So let's go ahead and find the domain. The domain would be from 0 to positive infinity, not including 0 because it doesn't touch the line, although it hugs it and gets close. And then we have our range. Because we have arrows on both ends, it's going to extend all the way up to positive infinity and all the way down to negative infinity. So our range would be from negative infinity to positive infinity. And there's the graph of log base 3 of x. We can also sketch this function by finding ordered pair solutions and then plotting them on the graph to sketch. So here, let's go ahead and find a few ordered pair solutions for this function. We'll go ahead and let x be 1, and then again we'll let x be 3, and then let x be 9. So let's start with the first. If we remove x and replace it with 1 in the original function, what we have here, we're going to rewrite it in exponential form. 3, remember that circular pattern, raised to the y power equals 1. So 3 raised to what power is going to give you 1? Well, you should know that any number raised to the 0 power equals 1. So therefore y equals 0. So we have one ordered pair. When we input a 1 for x, what we get out for y is a 0. Now if we plug a 3 in for x, let's see what we get out for y. So that would be 3 raised to the y power equals 3. So what number will 3 have to be raised to in order to have a result of 3? If you said 1, that is correct. So 3 raised to the 1 power is still 3. So when we plug in a 3 for x, what we get out for y is a 1. Let's do it one more time. This time if we plug in a 9 for x, so let's rewrite that in exponential form. 3 raised to the y power equals 9. So I need to find what number do I have to raise 3 to in order to get 9. And if you said 2, that is correct, because 3 squared equals 9. So when I plug in a 9 for x, what I get out for y is a 2. So we have enough points to get a general sketch of our graph. So we're going to go ahead and sketch it. And we also know that with a log function, it's going to have a vertical asymptote at x equals 0. And this is what our graph looks like. And there you have it, graphing a log function by finding ordered pair solutions.